describe the direction of the energy flow there. So when you have a physical change or chemical change, a fundamental part of it is energy. How do you define energy? That's another D word. Energy is the capacity to do work or transfer heat. That's how we define energy there. Okay? And work is defined as an action of force through a distance. So an example would be when you're trying to push a block on the floor. Okay? You have to use a certain amount of force, and the block moves a certain distance there. And the action, the force that you use, multiplied by the distance, that's the work you have done. And you probably see this, use this term, and you do a workout. You go to the gym there, you are running on the treadmill there, you're doing a lot of work there. So the force that you use to run on the treadmill multiplied by the distance that you run, and that's the work that you've done there. So this is how we define energy, and there are different types of energy. And again, we use many different terms to describe energy. One of them is kinetic energy. Now, kinetic energy has something to do with the motion of the object, whether the object could be a cinder block, or it could be as big as a cinder block there, or as little as an atom or an electron there. So when things are moving, there are a certain amount of energy associated with it. We use the term kinetic energy. Potential energy, however, has something to do with the relative location of that object. Say if you have a concrete block on the ground, and you use the ground as your reference point, we would say, well, there is no there is no kinetic energy or potential energy since you choose the ground level as your reference point. However, if you lift that block to a higher elevation, now you have to do work in order to do that. Okay? And if you put that block on the roof there, and we say that block has a lot of potential energy because the roof is way above the ground level where you have the your reference point there. Now, if you push that block off the roof, what happens there is that the potential energy stored in that block is being converted into kinetic energy because the object started moving there. And when it hit the ground there, it will de-shape the ground and it will actually release a certain amount of heat. So energy can be transferred from one form into another. So kinetic energy, potential energy can be transferred between one another. And the other form of energy, so thermal energy. Well, thermal energy is actually associated with the temperature change of an object there. It's kind of like a kinetic energy there, because when the energy flow, when the temperature changes there, it has something to do with the motion of the molecules there, motion of the atoms there, motion of the particles there. Okay, so normally when you talk about the energy there, and we use the term kinetic energy, potential energy. Now, how does this relate to the study of matter? That's the scope of the chemistry there. Well, when you have a chemical bond, when you have a compound that is formed, two different types of elements will react with one another. When they form a chemical bond, a certain amount of energy will be released into the environment. Now, you know when chemical reaction happens there, and if you have two different chemicals reacting with one another, forming new types of compounds there, you have to break out chemical bonds. And what happens there is that when you try to break chemical bond, you have to supply energy. So that process is an endothermic process, and you have to supply energy to break the bond. And then when the new chemical is formed, when the new chemical bond is formed, energy is being released. Now, whether a particular chemical reaction is endothermic or exothermic, releasing energy or requiring energy, it depends on the total amount of energy that we need to break all the old chemical bonds and the total amount of energy that will be released to form all the new chemical bonds there. And the difference between the two will determine whether a particular reaction is going to absorb energy or require energy input, or it's going to release energy. Okay, so we will have another chapter dedicated to the energy aspect of the chemical changes there, and we'll just want to introduce these terms when we're talking about the physical change and chemical changes there. So energy is always conserved, and that's one thing that you need to remember. You cannot create something out of nothing, okay? And it's only being converted in one form from one form to the other. So that's the law of conservation of energy. That's something that you always need to remember. Now, the system, well, when you have, say, a concrete block with high potential energy, will tend to change in a direction that lowers its potential energy. and releasing the energy into the surrounding there in the form of either heat or kinetic energy. So energy can be converted from one form to the other, and we will get into the details about the energy changes associated with the chemical physical changes there in chapter 6. So when we are talking about chemical changes and physical changes there, just want to make sure you also need to keep in mind there is an energy aspect of those associated with those changes there. Okay, so talking about the chemical properties and physical properties there, and we use gasoline as an example. Now here's another example there, hydrogen gas. We know hydrogen gas has a very low density. So the density is what we call a physical property. Okay, and you put hydrogen gas, well, probably people don't do that anymore, because the hydrogen gas is kind of explosive there, and they react violently with the oxygen. So you don't really put hydrogen gas in blue anymore. Rather, these days we use helium. Now there's a debate about the use of the helium there, and say, well, the helium is running out. We're using too much helium to inflate the balloons there. So that's another story, of course. And the chemical property of hydrogen gas, though, is that reaction between hydrogen gas with oxygen gas and generating water, H2O. Okay, so how do we differentiate between the chemical change and physical change, the chemical property, physical property? It has something to do with the types of change, with the composition of the matter that we are interested in. Okay, so that's something that we want you to pay attention. Now, giving you these definitions there, we want you to be able to answer these type of questions. Say if you have a piece of limestone, you heat it up. Okay? If you provide strong enough heating, and the limestone will decompose and will get into carbon dioxide and a solid lime. Is this a physical change or chemical change? Composition has changed. Limestone is different from carbon dioxide and lime. Okay? So this is a chemical change. Mixing alcohol with water. Alcohol is still alcohol, water is still water. They're just mixed together to form a homogeneous mixture there. So that's a physical change. Okay? And separating solid from a liquid by filtration. Physical. There is no chemical composition change, so that's a physical change. So this is the type of question that you will see in homework assignment in class, and we'll give you this kind of exercise there. And more than likely, when you take the first exam next Thursday, you will see these type of questions as well, similar type of questions. So you need to know definition in order to answer these type of questions there. Okay. Another practice here is that we give you some questions there. The normal color of the element of bromine is orange. Is that a physical property or chemical property? On the first slide that we used and talking about the physical change, chemical change, physical property, chemical property, color, taste, odor, that's physical. So this is a physical property. And iron turns to rust in the presence of air and water. Composition change, so that's chemical. Hydrogen explodes when ignited in air. Chemical reaction there. Density of titanium metal is 4.5 gram per cubic centimeter. Physical. It's a physical. Melting point. Tin melts at physical. It's a physical. And chloroform is ring. Color, taste, odor, physical. So these are the things that we need you to be able to do. Once we give you the definition, they're using the definition. You need to make. You need to be able to answer these type of questions. Right? So learning objective 1, learning objective 2.